Hi, this is Mr. Ye. Today I'd like to introduce you one of my favorite subject in AP Calculus is to talk about the relationship between f prime of x graph and f of x graph. So here we're going to show you this graph right in front of you is going to be f prime of graph, f prime of x graph. Now this is what f prime of. Let's go look it back and we say, hey, what does the original function look like? Original function look like the red function here, which is x to the 4 minus 4x squared. And so this is the original graph. We're going to use the first graph to predict the second graph, see if it's true. Now we're going to use this graph, which is f prime of x, that's what the test usually tell you, and ask you to predict this graph. Okay, so this is the original graph, but usually on the test they will tell you this is f prime of x. So if it's an f prime of x graph, then you're going to use this to predict what happened in the original functions. So here we're going to talk about certain things. Usually they will tell you says this is f prime of x graph. So in f prime of x graph, if f prime of x graph is above x-axis, okay, it's above x-axis, that means it's positive. And positive in f prime of x, that tells me the f of x is increasing. INC, I'm going to say that's increasing. If f prime of x is below x-axis, it's equal to negative. So that means f prime of f of x is decreasing. Okay, so those are the things that you should tell yourself when you recognize this, when you're looking for above x-axis or below x-axis. So here, there is a graph going like this, and we're going to go back and see this. We said f prime of x. Also, we want to talk about one more thing. It's one of the most common questions in the AP exam is ask you what's the critical points. So if something is critical points, that means f prime of x is equal to 0, or another thing is what people usually forget is undefined. So if something is undefined, then you can say, okay, well, let's look at f prime x equal to 0, and we're going to see where they're at. Here we find the 3 spots, right here, and right here. That's f prime of x equal to 0. Now, what happens if in original function, f prime of x equal to 0 can happen in original function is, first thing it can happen is relative min. Second thing it can happen is it can be relative max. And the last thing can tell you is some type of horizontal tangent, because sometimes you can graph like going like a flat and then not relative minimum, it will just keep on going up again. So it's kind of like a horizontal tangent. So sometimes it can happen like that. Now you're going to look at this, you say, okay, well, how can we tell they are relative min or max or horizontal tangent? So we're going to use a tool, it's called number line test. And this number line test is going to be negative 1.4, 0, and 1.4. So in this case, that if it's a positive, which is above below x-axis, so it's negative here. So it's going to be negative here. So if it's above x-axis, that means this is a positive. Okay, does that make sense? Now you just have to look at it. Are they below x-axis or above x-axis? That's why I address it in the front. So this one's below, so it's x-axis, so it's going to be negative. And here it's going to be above x-axis, so it's positive. So look at this case, then you can say that's decreasing. It's increasing, decreasing, increasing. So usually I would address from this part, I can say, okay, that means if it's decreasing and increasing, so if something is decreasing and increasing, that means it's relative min. And if it's increasing to decreasing, means go up and come back down. That's relative max. And here it's going to be relative min. So by looking at this, I can address from this already. However, AP exam don't want you to write like this. Okay, so if you write like this, you're not gonna get credit. So you have to pay attention how you write it. So here's I'm gonna show you how do you write it. So here we can say it's f prime of x. We can say, okay, let's give you something first. When a function is f of x is increasing interval, so increasing at negative 1.4 to 0, union from 1.4 to infinity. Decreasing at decreasing is at negative infinity to negative 1.4, union from 0 to 1.4. So that's the all the information I can give from the things, and that's how you're gonna adjust to the AP exam for AP grader. Now, if they would ask you when does relative maximum occur, then you have to say, okay, relative maximum occur at x equal to 0, and relative minimum happen at x equal to this. So be negative 1.4 and x equal to 1.4 is relative minimum, right? And then you can say it's because relative minimum is when from decreasing to increasing. So if you see here decreasing to increasing, that means this point is relative minimum. Decreasing to increasing, that's relative minimum. So how do you justify? If AP exam wants you to justify, you're gonna say, well, you're gonna write like this: f prime of x change from negative, because it went from negative to positive, so negative. So negative to positive at x equal to negative 1.4 and x equal to 1.4. So then you can say due to the first derivative test, so first derivative test, okay, first derivative test, you can say due to the first derivative test. So that's how you're going to say it. You don't have to write down first derivative test, but for me, this is the first derivative test I want to address to you. There's also something called second derivative test, and second derivative test is used for something else, but it's also tests whether they are relative maximum and minimum, but due to using the increasing due to using looking at the concavity of the functions or the second derivative. So this is the first part, and let's go see if our prediction is right. Our prediction says negative 1.4 and 1.4 is relative minimum, and the 0 is relative maximum. Let's see if it's true. And let's look at it. This is true because this relative max and this 2 point here at relative min. And this is relative min. And that'll be all. And next time we can talk about how do you use the second derivative test, and how do you find the inflection point of this graph. But we had to look at a second derivative, which is we're not looking above or below x-axis anymore. So hopefully you enjoyed this video, and this is crash course number 1. Thank you for watching.